small one, but now I'm scared. Looking at you, trying to see your stalling. Ooh, one hesitant step ahead. You're another small one, but now you're scared. Looking at you, trying to see where you're crawling out. Emergency, oh.
Guys like you always have interesting stories to tell, so please go give a nice welcome to Victor. Give a applause and then we'll start.
Hello, my name is Victor, and I'm going to catch you up with my excitement about the Swagger framework. I'm doing software development for almost 15 years now. And in the past year, I served as a chief architect at Support Space. My main goal during this time was to migrate Support Space platform from a monolithic Java application to a service-oriented architecture. The main challenge was to understand how to separate to the services and what is the best way to build them. And I first learned that the important ingredients of service-oriented architecture are APIs. There is a need for decoupling, and APIs are going to serve this role well. I also understood that also API are consumed by machines. The real users of the APIs are humans, are developers. The successful APIs is the one that is easy to consume. It is easy to write client application. And also is that the crucial part of it is the API documentation. So with these insights, we've started our journey at Support Space and started to define our documentation format. We used Confluence, and we defined our own page format in Confluence, in which you can see the API details, operation names, HTTP methods, various parameters, and return types. I believe you may have similar pages on your organization as well. So the issue was that we could not achieve a standard. We tried to do it, but with each and every API, we may have some new attributes, and we needed to add them. But what happens to the pages we already created? How we update them? Every time the API signature was changed, we needed to go manually to these pages and change them. And guess what? We did not do it that well. The API became unsynchronized with the actual application code in production. So it was a mess. I started to look for another solution, and I wished to have some user interface in which I could see the list of the APIs. For each API, I could see a description or some other details. When I drill down to a specific API, I wished I could see a list of the operations, what are the HTTP methods, and a description of each and every operation. If I would go further, I want to see the details about each and every operation. What are the parameters and what are the return types? But the most important part, I want this documentation to be in sync with the actual application code. So I found Swagger. Swagger is a technology. First of all, it's a framework that helps to implement, to build API. It helps both on the server side to produce the API. It helps on client side to consume the API, and it's very helpful. From the other side, and I believe this is much more important, Swagger is a framework. is also a specification, and it's specification that helps to describe and eventually document the API. And as such, it's also helpful to build a methodology for actual API development. Swagger is built around the JSON, like many things these days. You can define a JSON that specify the API metadata, say API version, basic URL, and etc. You may have another JSON that specify API structure. What are the operations and all the details about them. Swagger also adopts another emerging standard in the industry called JSON schema. JSON schema is a standard in which you can specify entities of your system. It's a JSON in which you write what are the field name, type, whether it is required or not, and many more details. It's similar to XSD and XML world. So Swagger uses the JSON schema to specify a model of the APIs. The fact that Swagger specification is around JSON make it machine readable and also language agnostic. You know, these days every framework, every language capable to deal with JSON. So it was an introduction, and further I go deeper to the framework itself. We'll highly describe the technology. I will talk what Swagger is not about, what are the alternatives. But I believe the more important part of this talk is the discussion about the process, both development and the deployment process of the APIs. So as already you may guess, the UI that I've shown before is actually a Swagger UI. It is a built-in default UI that comes with Swagger, and on the main level you can see the list of the APIs. Behind this UI there is a JSON that describes the API. You can see you can specify actually the API version, the Swagger version that you are using here. You can see the list of the APIs. For each of the APIs you can see its details. You can specify a description of this API. And if you are in JVM world, you can also annotate the actual API code with Swagger annotation. If it's not a Java world, there are solutions as well. Okay, then you go drill down to the actual API, and you see the list of the operations. For each and every operation, you can see the parameters, what are the types of the parameters, and what are the types of return types. And actually, what also interesting, you can try your API right away. The default built-in Swagger UI provides a form which is built automatically and you have an input for every API parameters. If it's string, you have text field. You can also specify in Swagger specification what is the list of allowable values. In this case, Swagger UI will provide the combo box with these details. And you have the button Try It Now. It will actually invoke the API and it will display the result. Very handful during the development of the APIs. And guess what? There is another JSON behind this information. There is a JSON that specifies operations that you have, as you can see on the left side. On the right side, this is the example of JSON schema I mentioned before. And this is another example of Java annotations. Swagger is developed by a company called Reverb, and Reverb makes tools for content understanding. They have an interesting API called Wordnik, and this API provides some information about various words. Reverb implemented Swagger for the internal use initially, and then contributed it to the open source. Interestingly enough, Reverb also developed other open source projects such as Atmosphere, Scalatra, JSON4S, very interesting. From a technology perspective, the base of the framework is a Scala code, and it has three basic building blocks. There is a Swagger core, which is actual implementation of the framework. There is a Swagger CodeGen. It's a set of utilities to generate client-side code. And the Swagger UI is this default built-in UI that we just saw. From the server-side perspective, Swagger comes with a bunch of server-side integrations. Many frameworks are already capable to run Swagger. It's Python, Django, Node.js, many JVM-based framework, JAX-RS, Grails, Scala, many, many more. For client code generation, Swagger uses Mustache templates. There are already utilities to generate client code in Java, Ruby, Python, C#. You can write your own custom templates. And actually, recently I've contributed a template that generates Groovy code, a Groovy client code that uses an awesome Groovy HTTP builder. Swagger does not support multiple API version. It is very important part of API development, but I believe it should not be too difficult to extend Swagger for this purpose. In the industry, there are many debates about what is the right way to develop API. There is REST by the book. There is a pragmatic REST, and many other approaches. And Swagger will work wherever you will choose to implement your API. It actually does not care how API actually built. You can just specify the structure of the API in the Swagger way whenever you've chosen to implement it. The basic philosophy of Swagger framework is not to try to solve each and every problem for all the APIs that there are. There are some issues that they are just not trying to solve. In the traditional web services world, there is SOAP and WSDL. And I guess Swagger is somewhat inspired by WSDL, but Swagger is much, much more simpler than that. WADL is another industry standard that was designed to be similar to WSDL, but for REST API. But I guess for the reason that WADL tries to solve many problems, it is not that adopted in the industry. Meshery IODocs is a commercial tool. It's quite similar to Swagger. It has a nice UI as well. They say that there is also an open source license. They think that I could not find that much documentation about it open in internet. You know, you do need a documentation for the tool that generates documentation. I guess for the commercial product, you may find it a better one, but I did not try it. There is another commercial tool called API Array.io, and you can always build your own tool. The rest of the talk is actually a suggestion for development and deployment process of the API. I actually invite each and every you to discuss, and I will glad to hear what you think is the right way to go. As for the API development, I can see two approaches. You can start with the specification first. You can write the JSON that specify the API, and then you may have two different teams run in parallel. The client-side team can just take these specs, these JSON files, generate the client code, and embed it in the client-side application. The other team may take these specification files and automatically generate stubs for the server-side framework they chosen to use, and then actually implement the API and publish them. And from here, the two teams can come back and work together. The other approach is to start right with the implementation. And Swagger supports this approach as well. As you could see previously, you can annotate your existing API implementation code, and then you can just generate the documentation just as is. These ideas for the approaches are not new. They're quite similar to what is similar to relevant approaches in the traditional SOAP world. What is the issue with the deployment? So far, we placed our annotation, say, on our code, on our code that goes to production. In development and test environment, it's just very helpful and it's wonderful. But in production, there might be issues. For example, you may not want that that there will be a traffic to your production environment just to see the documentation. It may be okay, but you may not want it. From the other hand, you just saw that the basic out-of-the-box UI of Swagger comes with an ability to invoke the APIs. Again, it's not something that you may want on production environment. There could be various solutions. You can just customize the UI that is come with Swagger and just remove these areas if this production environment. Swagger comes also with some authentication implementation. But I'm going to suggest another approach. In the development and test environment, just do what we just saw. Go ahead, annotate the APIs, and make Swagger UI accessible from the application itself. It is very useful on the development and test environments because you can just view the documentation. You can test the API with the Swagger UI in place. And actually, if I mentioned previously the service-oriented architecture, you can generate the internal clients for the same services that plays a client-side role. But on production environment, we may want to make a Swagger UI not accessible from the application itself. And you can, for example, to block this UI URLs on production, so it will not be accessible. But then you will use an automatic task that generate the static resources that specify the API and the static resources for the actual UI, and using Swagger tools. Actually, again, these days I'm working on implementing a Gradle plugin that will do this job. Gradle is another interesting technology that I'm excited about, and then you will be able to generate all these static resources automatically. Then you may have a dedicated web server, say Apache or Nginx, that will host these static resources. You also will need to make sure to synchronize the documentation with the actual application code. So if you go and deploy a change to the API on production environment, you need to make sure that you have some automative process that will take this code, generate the static resources, and automatically deploy to this dedicated web server. So now the external parties, your customers, partners, etc., can go ahead, generate their client application, and they can work against some web server which is not the actual production environment. And it may ease your production setup, and you may not worry if the parties that go to see your documentation and work with your API will interfere with your actual production environment. As for the references, I can point to Swagger Home. There is a bunch of documentation. There is a Swagger specification details on Wordnik GitHub account. You can see there are many tutorials for various server-side frameworks. I could also, from my personal experience, tell you that you should be aware about recent change in the implementation. There is a new version of Swagger 1.3. And if you used 1.2 and upgrade to 1.3, make sure you upgrade all the sides. I mean, also the implementation, the client side, the documentation. It may be painful if you not pay attention. There is a Swagger pet store demo online, and you can just play with it. And there are some real-world implementation with Swagger, and one of them, of course, the Wordnik API. And there are many more. So go ahead, make your API accessible, and use Swagger. Thank you very much.